Hello everyone. We are solving this paper, which is paper 4 mechanics, Feb March 2024, variant 42. Now let's look at the first question, and we are starting the paper at 3:05. So now the question says, the displacement of a particle at time t seconds after leaving a fixed point O is s meters. The diagram shows a displacement time graph. Displacement on the vertical axis, time on the horizontal axis, displacement in meters, time in seconds, which models the motion of the particle. The graph consists of 4 straight line segments. The particle travels 50 meters in the first 10 seconds. In the first 10 seconds, the particle travels 50 meters, then travels at 2 meters per second for a period of 10 seconds. Then we are talking about this line segment. And then the particle comes to rest for a period of 20 seconds. Time is passing, but the displacement is not changing. That means the particle is at rest before returning to its starting point when t is equals to 60. First part, find the velocity of the particle during the last 20 seconds of its motion. Now, first of all, let me just mark some straight lines over here. So that is the first portion of the graph. And then we have this blue portion, the second one. And then the third one, the rest portion. And then the fourth one is returning to its original point, the starting point. So now over here, this is 50, this is 10. And over here, the blue portion, the gradient is 2 meters per second, because the gradient of a distance time graph is speed. So therefore, if it's displacement and time, it's velocity. So mark this point, mark this point. Let's get started. So therefore, s minus 50, that is the change in a displacement, divided by the change in time, which is 20 minus 10. This equals to 2. S minus 50 equals to 2 times 10. Therefore, s comes out to be 50 plus 20. Therefore, s is 70. Therefore, the value over here, that is 70. But we are interested in the velocity over here. So therefore, over here, the change in displacement over the change in velocity, that would be the change in time. That would be what? That would be the velocity during the last 20 seconds. So we needed to find this thing, the 70 over here. So now the change is from 70 all the way till 0, and the change in time is 20. So therefore, the velocity is 70 divided by 20 with a negative sign, because we can see that the slope is negative. So this comes out to be negative 3.5 meters per second. That is the velocity for the last part. If it would have asked for the speed, we would simply say that ignore this negative sign and just give the magnitude. Now it says sketch a VT graph for the motion of the particle from 0 till 60. So let me draw some straight lines. This is the y-axis, so I need to get the scale over here. And I need to get it a bit straightened out like this. And this is the x-axis. And let me just change this thing, resize. And this is good. Now over here, what do we have? For the first portion, over here, we have 50 over 10. So the speed is 5 meters per second. Then it's 2 meters per second. At rest, this is 0 meters per second. And this last portion, it's negative 3.5 meters per second. That means all these velocities are constant. So there will be flat line segments over here. So 0 till 10 till 20, 20 till 40. So let me mark some values. So 0 till 10 and 10 till 20, 20 till 30, 30 till 40, 40 till 50, 50 till 60. This is time in seconds. And this is the velocity in meter per second. So the greatest value of velocity is 5 and the lowest value is negative 3.5. So let me mark over here. So this is like 1, 2, 3, 4, 5. And over here, -1, -2, -3, -4. So this is -4 up till here. So now this portion over here, that is 5 meters per second. That's constant. The gradient is constant. The gradient is velocity for first 10 seconds. So for first 10 seconds, the gradient has a value of 5. So just draw a line like this over here. That is this thing. So that goes like this. And again, I forgot to take out the ruler. So that goes like this. Then we have the blue portion, that is 2. For how many seconds? 10 till 20. So we have 2 over here. And this is 10 till 20. That is this portion. The third one is 0. That's from 20 till 40. So the green portion from 20 till 40, that is the particle is at rest. The velocity is 0. The last portion for 20 seconds is -3.5. So we have this thing, and this is -3.5. And we need this thing. So that is 40 till 60. Of course, I'm not having a ruler. So I'm just making rough lines. So therefore, this is 10. And this is like this. And this is like this. So this portion, that's how the graph is. I can just erase this portion up to here. Okay, so these are the different portions that are drawn over here. So that completes question number 1. Let's move to question number 2. It says a particle is projected vertically up and from horizontal ground. The speed of the particle 2 seconds after it is projected is 5 meters per second, and it is traveling downwards. Find the speed of projection of the particle. That is the first part. Now, what is happening is that, let's say this is the ground level. The particle is thrown from this level up with a speed of u meters per second. It travels up. It reaches its maximum height. On the way down, somewhere over here, the speed is 5 meters per second. It's acting downwards. Now it's asking for the speed of projection. So what we can do is that we know that the speed at the maximum is 0. That is 0 meters per second. So why don't I take 0? Why don't I take 5? Why don't I take the acceleration due to gravity as plus 10 meters per second square? I find the time taken to travel this portion. So therefore, v is equals to u plus at. I'm taking v to be 5, u to be 0 for this portion traveling down, and a is positive 10 into t. So t comes out to be 0.5 seconds. That means for the rest of the journey, 2 minus 0.5 is 1.5 seconds. It started from this point. It traveled all the way up till the maximum height. So therefore, I'll write time is 1.5. Acceleration due to gravity is -10 meters per second square because it's going up. And v is 0. So let's find the value of u. So v is equals to u plus at. 0 equals to u, which is u, and a is -10, and t is 1.5. So therefore, u plus u -50 is equals to 0. Therefore, u is 15 meters per second. This is the velocity, the speed of projection. Now, the next thing, that is, find the distance traveled by the particle between 2 times at which the speed is 10 meters per second. So now what we can do is that we can just make use of this thing. What if we started at 0? And somewhere over here, the speed will be 10 meters per second. And we can find the maximum height, subtract this distance, and then we know what is the height that is left. Actually, we need this distance and this distance, the 2 times for which it's traveling between the speed is 10 meters per second. So the speed will be 10 meters per second when it's going up and 10 meters per second when it's going down. So what we can do is that, and we need the distance. So now let me write u as 0 velocity as 10 meter per second. U is the initial, V is the final, A is plus 10. And let me write V square is equals to U square plus 2AS. So this is 10 square, this is 0 square, this is 2 into 10 into S. 100 is 20S, therefore S comes out to be 5 meters. That means from 0 till 10 meter per second, it is covering a distance of 5 meter. The same reciprocity would be applied when it's traveling up from 10 meter per second to 0 meter per second. So this will also be 5 meter. So find the distance traveled. So therefore, the distance traveled is 5 meter going this way, 5 meter going this way. Therefore, the total distance is 10 meters. Next question. Now it says, a crate of mass 600 kg is being pulled up a line of greater slope of a rough plane at a constant speed of 2 meters per second by a rope attached to a winch. The plane is inclined at an angle of 30 degrees to the horizontal and the rope is parallel to the plane. The winch is working at a constant rate of 8 kilowatt. Find the coefficient of friction between the crate and the plane. So now what we can do is that a small diagram will be beneficial. So let me draw a plane like this. That's kind of light. So let me use this color. And that goes like this with a ruler kind of thing. So now it's being pulled up. And the power is 8,000 watt. So that is 8,000 divided by 2. And there is a resistive force, which is the frictional force. So let me write F max over here. And does it move at a constant speed? Yes. That means the acceleration is 0 meter per second squared. And of course, there should also be a weight component acting downwards. So this is 600 G sine of 30 degrees, where 30 degrees is the angle with the horizontal. So therefore, I'll say 4,000 is equals to F max plus 600 into 10 into sine of 30, which is 0.5. So 6,000 into 0.5, that is basic calculation. This is 3,000. This is 4,000. This is F max. So let's make F max the subject. That comes out to be 1,000 Newton. But we know that F max is equals to mu r. So on an inclined plane, what is the normal reaction force? The normal reaction force is equals to mg cosine theta. In this case, it's 600 G into sine of 30 degrees. So therefore, F max is mu r. So that is mu into 600 G sine of 30 degrees is equals to 1,000. So make mu the subject. That is 1,000 over 600 into 10 sine of 30. I can actually, it's cosine of 30. Let me correct myself. So this is cosine because sine is along that thing. So therefore, this is cosine, this is cosine, this is cosine of 30. So now let's use a calculator. And this value comes out to be 0.1925, which can be rounded to 0.193. That is the coefficient of friction. So something very basic. Question number 4. It says 4 coplanar forces act at a point. So that's a point, and these are the 4 forces. The magnitude of the forces are such and such. The direction of the forces are as shown in the diagram. Given that the forces are in equilibrium, find the value of F and the value of theta. Now, my strategy always is that make sure angle is with the horizontal. So even if it's with the vertical, just subtract it from 90 and write it as the angle with the horizontal. Now, it's a totally separate thing. That sine of 45 is equals to root 2 over 2, which is the same thing as cosine of 45. That means in this particular question, if I mistakenly write sine 45 instead of cosine 45 or vice versa, I'll still get the same answer. But we shouldn't compromise on our standards. So that's the standard that I've set up. Make sure the angle is with the horizontal. What's the usage of this? The usage is that the horizontal component will always be in terms of cosine and the vertical component will always be in terms of sine. Now, first of all, what are the four forces that we have? So the first force that we already have, that is this thing, which is 3F. So let me just make this line thicker. Then 2F, it can be broken it up into two parts, this one and this one. That is for 2F. Actually, let me just draw it like this. And then the third force, that is 30 Newton. That is going this way and this way. Actually, that's the fourth one. And the third one is right over here. Or let me make it purple. So now we have four forces. 3F remains as 3F, F remains as F, 2F is broken down. So this is 2F cosine of 45 degrees, which is 2 into root 2 over 2. What does that comes out to be? That comes out to be root 2F. And similarly, this one is 2F sine of 45 degrees. Sine of 45 is also the same thing. So therefore, this is also root 2F. Similarly, over here, we have this angle theta. So this is 30 cosine theta, and this one is 30 sine theta. And this force needs no resolution because it is horizontal. This force needs no resolution because it is vertical. So now the upward force is equals to these two downward forces. So 30 sine theta, let me write it white marker, 30 sine theta equals to F plus root 2F. And the other equation is this, the leftward force equals to sum of the two rightward forces. So 30 cosine theta equals to root 2F plus this one is 3F. So this is 3F, this is root 2F, and this is 30 cosine theta. This is 30 sine theta. F is downwards, root 2F is downwards. So now this is looking all good. Let me simplify it further. So let me take F common out. This is 1 plus root 2. This is equals to 30 sine theta. Let me write this as equation 1. And over here, this is 30 cosine theta is equals to F root 2 plus 3. This is equation 2. So we know that sine over cos is tangent. So if I take equation 1 and if I divide by equation 2, so therefore this is 30 sine theta is equals to F1 plus root 2 divided by 30 cosine theta. This is F bracket root 2 plus 3. So now what happens is that the F cancels with the F and the 30 cancels with the 30. And we are left with tangent of theta is 1 plus root 2 divided by root 2 plus 3. And we are looking for theta, we are looking for F. So theta is tangent inverse of this value, 1 plus root 2 over root 2 plus 3. Naturally, you would plug in the calculator, you would simplify, and therefore theta comes out to be 28.675, which can be written as 28.7 correct to 1 decimal place. Similarly, if I plug theta in any one of the equation, for example, if I plug in the first equation, sine theta is equals to 30 sine theta equals to F bracket 1 plus root 2. So therefore, I'll write 30 sine of 28.675 divided by 1 plus root 2 equals to F. So therefore, F comes out to be 5.9627, which can be written as 5.96 correct to 3 significant figures. Angles in degree, the final answer to 1 dp. Any other non-exact answer correct to 3 significant figures. So question number 4 is completed. Let's move to question number 5. Now the question says, and let me check just one thing, the recording thing. I'm always suspicious of that. Yes, it's going all good. So now the question says, a particle moves in a straight line starting from a point O. the velocity v meter per second of the particle t seconds after leaving O is given by such and such. This is the equation. It is valid from 0 till 4. You may assume that the velocity of the particle is positive for t is less than half, is 0 at t is equals to half, and it's negative for t is greater than half. First part, find the distance traveled between 0 and half. So we know that the displacement equation can be found, and then the distance can be calculated, or directly distance can be found by integrating between the limits. In this case, it's 0 and half. So this is t cube minus 9 over 2 t square plus 1 dt. So therefore, this becomes t power 4 over 4 minus 9 over 2, and t square becomes t cube over 3, and 1 becomes t between the limits 0 and half. Simplify it a bit. T4 over 4, 3 ones are 3 threes are, that is negative 3 over 2 t cube plus t between the limits 0 and half. So when we plug in 0, everything will be cancelled out. So it's kind of useless plugging it in. Just plug in half. So therefore, this is 1 over 4. This is 1 over 2 raised to power of 4. This is 3 over 2. This is 1 over 2 raised to power of 3. And this is 1 over 2. So this is 1/4, and this is 1 over 16. This is 3 over 2, and this is 1 over 8. And this is 1 over 2. So this is 1 over 64. 2 into 8 is 16. This is 3 over 16 multiplied by 4. Multiplied by 4, that can be written as 12 over 16. So I've written this as 12 over 16. 1 over 2 can be written as 32 over 64. I just want everything with a denominator of this thing. So let me just correct myself. This is 64. And let me write it properly over here, because 3 over 16 into 4 divided by 4, that is 3 over 64. So 3 into 4 is 12, 12 over 64. So 32 and 34 and 44 plus 1, this is 45 over 64, if I'm not mistaken. So therefore, this answer comes out to be this. But wait a minute, there was a negative sign. So yes, I forgot the negative. So therefore, 32 minus 12 is 20. 20 plus 1 is 21 over 64. So that is the answer. That's right over here. So just take care of the plus minus sign. In these calculations, they're pretty simple. But when we plug in the limits, there's too much of numbers all along the place, all around the place. So just take care of that. Now it says, find the positive value of t at which acceleration is 0. So we have v equals to, let me write it again, that is t cube minus 9 over 2 t square. This is t cube minus 9 over 2 t square plus 1. Therefore, acceleration is dv by dt. That equals to 3t square minus 9 over 2t square becomes 2t, 1 becomes 0. So therefore, this is 3t squared minus 9t, which can be written as 3t common, t minus 3. This is the acceleration equation, at which the acceleration is 0. So a is equals to 0. We are looking for the turning points of velocity. In other words, 3t, t minus 3 equals to 0. Therefore, t is 0. That is the start of the journey. T minus 3 equals to 0. Therefore, t is equals to 3. Now it's asking for find the total distance traveled between t is equals to 0 and this instant. Now, there were some hints over here. You may assume that the velocity of the particle is positive for this range, 0 at this value, and negative for this. That means the velocity is negative. That means the particle is turning around. So this is in one direction, this is in the other direction. So you cannot calculate the complete distance directly. What we do is that we write it like this. So displacement is 0 till half, which is already done. This is t cube minus 9 over 2 t square plus 1 dt. And this answer was 21 over 64. And similarly, calculate the distance from half till 3. And it's the same thing. That is t cube minus 9 over 2 t square plus 1 dt. the integration was already done and simplified. T4 over 4 minus 3 over 2 t cube. That is T4 over 4 minus 3 over 2 t cube plus t. And now the limit is half and 3. Now, the value for half was coming out to be 21 over 64. So I don't have to repeat the working over here. So what I can do is that I can write this thing. That is 3 power 4 over 4 minus 3 over 2. That is 3 cube plus 3 minus this value, which is done for half. That is 21 over 64. And this time, what has happened is that this answer, if you use a calculator, this comes out to be negative 1125 over 64. So we are working from half till 3. So now when we have this answer, what happens is that, let me illustrate this idea using this thing. So now I have drawn this curve over here, and this is the curve of the same function. And you can see very well that this value is exactly half. Between 0 and 0.5, the velocity is positive, and then 0.5 all the way till the end, and it's going till 4.5, but we just want till 4. This value is negative. The velocity is negative. That means portion of the graph, let me take a screenshot of this. And let me just show you this thing in a little bit more detail so that you have a pretty good idea. So let me just make it like this. And I'm saving it. And let me just plug it in over here. So I'll just insert this thing. That's right. So now let's focus on this. So basically, from 0 till half, the velocity is positive. Therefore, this region is above the x-axis. And over here, from half till 4, I think it kind of like, this is the 4 value. This region is below the x-axis, and this is coming out to be negative. So discard the negative sign. And what do we have? We have this coming out to be 1125 over 64. So now add up the areas, which are the distances, and this comes out to be 1146 over 64. And this can be written as 17.9 meters. That is the answer for this particular part. So that was the special thing about this thing. That is t lesser than half, the velocity is positive, and t is equals to half, it's 0. That is like the value when v is 0 and t is greater than half, it is negative. So that's how this particular question is completed. So let's continue with the next question. That is this thing, which is question number 6. Now the question says, a car of mass 1800 kg is towing a trailer of mass 300 kg up a straight road inclined at an angle alpha to the horizontal where sine alpha is 0.05. So first of all, I'll just get a diagram drawn. That is the first basic thing that I should be doing. This is like an inclined plane. And over here, there is a car. And this car is pulling a trailer. And yes, there will be some tension over here. So that is this trailer that's right over here. And the mass of the car is 1800. So let me just mark it. So the mass is 1800, mass of the trailer is 300, angle is alpha. So this is alpha over here, and sine of alpha is 0.05. Now they're connected by a tow bar, which is light and rigid, and it's parallel to the road. So that always is the case. There is a resistance force of 800 on the car and resistive force of F Newton on the trailer. So resistance force, resistive force on the car is 800 Newton. And on the trailer, that is F Newton. And then the driving force of the car's engine, that is 3000 Newton. Now it says it is given that F is 100. So the value of F is 100 Newton. Find the acceleration of the car and the tension in the tow bar. So now over here, what do? We write 3000 minus tension minus 800 minus 1800 G sine alpha equals to 1800 A. This is necessary. Now let me calculate 1800 G sine alpha, that is 0.05. This comes out to be 900. So the weight component is definitely there. That is 1800 G sine alpha. And the weight component of trailer naturally will be there. That would be 300 G sine alpha. The next equation for the trailer would be T minus 100, which is F minus 300 G sine alpha is 300 A. Now let me also evaluate 300 G sine alpha, and this value is coming out to be 300, actually 150. Because 1800 divided by 6 is 300, everything else is the same. So 900 divided by 6 is 150. So now let me add up the two equations. So let me draw a straight line like this. So now I'm talking about the equation of the system. The tension will cancel out. So now we have 3000 minus 800 minus 1800 G sine alpha, which is 900, minus this 100, minus 300 G sine alpha, which is 150. This equals to 2100 A, that is adding these two terms. So therefore, 8 and 9 is 17, 18, and this is 1950. So 1050 equals to 2100 A, and we get a beautiful answer that is 0.5 meter per second square. That is the acceleration of this whole system. And the tension in the tow bar, so let me plug it in equation number 2, this one. So T minus 100 minus 150 is equals to 300 into 0.5. So this is 150, and T minus 250 is 150. Therefore, T comes out to be 400 Newton. That is the tension in the tow bar. Now let's look at this part. The question says it is given instead that the total work done against F in moving a distance of 50 meters up the road is 6,000 joules. The speed of the car at the start is 20 meters per second. Use energy method, find the speed of the car at the end of 50 meters. Now this is that work energy principle. Let me write it down. Work done by engine, that should equal to change in potential energy plus change in kinetic energy plus work done against resistances. Now, first of all, let me start with the resistances. The total work done against F. Now, F was the resistive force on the trailer. So this has a value of 6,000 joules. But there is also a car. And is there any resistive force on the car? Yes, there is. That is 800 Newton. And it's acting a distance of 50 meters. So this is 8,000 into 50. That comes out to be 40,000. That means take the 6,000, take this 40,000. So first of all, let me write the things over here. That is work done against resistance for the system. That is 46,000. That is the first thing. Now let's move to the change in potential energy. Let me write it in blue color. It's going uphill. So therefore, change in potential energy is positive. That is M, which is the combined mass of car and trailer, into G, which is 10, into H, actually the distance along the plane, which is 50. And we will calculate this thing, but there is also the thing that either you use mg sine theta into distance along the plane, or you use mgh. Now, since 50 is the distance along the plane, don't forget sine theta. So let me also multiply it with sine of alpha, which in this case is 0.05. So you have to multiply this out. So do not mix up the two things. Now, when we multiply it out, that is 2100 into 10 into 0.05 into 50, that comes out to be 52,500. Let me write this in blue so that we know that this is change in potential energy. What about the change in kinetic energy? So we will say change in kinetic energy, that is half into 1800 plus 300 multiplying with v square, the final velocity square minus the initial velocity square. So that is 104050, my bad. And this is v square minus 400. So that is this change in kinetic energy. And work done against resistance was actually this one. And now we are interested in work done by engine. So work done by engine should be the engine force, which is given over here. That is 3000. So that is 3000 into 50. 5 into 3 is 15, and then 4 zeros, so 150,000 joules. So all this thing is in joules. And now place things where they belong. So first of all, 150,000, that goes over here. And then equal sign, change in potential energy, that is equals to 52500 plus change in kinetic energy, that is 1050 v square minus 400, and also work done against resistance, that is 4600. So that's how things are written. Let me make v the subject. 150,000 minus 46,000, I forgot a zero. So now it's negative 52500, negative 46,000 divided by 1050. And this comes out to be v square minus 400. So therefore, v square is 400 plus 49.0476. Therefore, v is square root of this value, and v comes out to be 21.19 meter per second, which can be written as 21.2 meter per second, given correct to 3 significant figures. So that was a slightly challenging question in which you have to take care of everything. So question number 6 is done. Now comes question number 7. And usually we know that question number 7 requires a lot of time. Now remember, we started at 3:05 and then I took a water break. So let me just double check this. So 3:05 and this is 3:48 right now. So 3:05 till 3:48 with a short break in between. So I did question number 1 all the way till question number 6. So therefore, let me write this thing as 3:08 till this thing. So in 40 minutes, I'm able to handle 6 questions, which is perfect. That means now I have all the time to do question number 7 comfortably. So for you people, if you can handle 1, 2, 3, 4, 5 in the first 40 minutes, and then 6 in the next 15 minutes, and then 7 in the next 15 minutes, more or less. So that is 40 plus 30, that is 70 minutes. So with all the rechecking and everything, you should be able to do your paper 5 minutes earlier than the required given number of minutes. So coming back to this. Now let's look at this question. The working is very simple. Minimal use of calculator is there, but it's very conceptual. Now it says, the diagram shows 2 particles, P and Q. This is P, this is Q. P is higher than Q. And particles P and Q are each of mass n kg. The plane is inclined at an angle theta. Sine of theta is 0.6. So first of all, I might be needing cosine theta. So sine of theta is 0.6. That can be written as 3/5. So therefore, this is 3, this is 5, this comes out to be 4. So cosine theta is 4/5 or 0.8. So that's the first thing that I've done. Then it says the length AB is 0.75. So let me just highlight this thing. So let me make it a bit thicker. So this thing, the length AB, I need the straight edge. This length is 0.75. And then it says the length BC is 3.25. So the length BC, the blue line, this is 3.25. AB is smooth. So we have AB, which is smooth. And we have BC, which is rough. The coefficient of friction is 0.25. Particle P is released from rest at A at the same instant particle Q is released. So both the particles are released at the same time. Now, first of all, for 3 marks, verify that particle P reaches B 0.5 seconds after it is released with a speed of 3 meters per second. So something very, very basic. First of all, for the portion AB, that is this orangish portion. So let me just draw this line like this and something like this. For this portion, this is A and this is B. So now we know that the initial velocity is 0 and the distance is how much? That is 0.75 meter. Now we need acceleration. So just a rough diagram over here. This is mg sine theta. There is no resistive force equals to ma. So mg sine theta equals to ma. Therefore, A is g sine theta. The value of sine theta is 0.6. So this is 10 into 0.6. This comes out to be 6 meters per second square. So that is the value of acceleration. Now, when you work with such a limited space, make sure all your things are intact. So start with the very left and try to gather everything in one place. So that is the first thing that's done. And let me just remove this thing. That is this A over here. And let me just draw it like this. Okay. Now the next step is, let me take this thing. U is 0, S is 0.75, and A is 6 meters per second square. I can do 2 things. V is equals to U plus 80. And the other one is V square. I'll use this later. I want to avoid the quadratic equation. So therefore, let me first write V square is U square plus 2AS. I'm talking about S is equals to UT plus half AT square. So therefore, V square is 0 square plus 2 into A, which is 6, into S, which is 0.75. So 2 into 6 is 12. 3/4 of 12 is 9. Therefore, V comes out to be 3 meters per second. That is done. Plug it in over here. 3 is equals to 0 plus 80, which is 60. Therefore, T comes out to be 0.5 seconds. So both these parts are proven. That is the first part. Now, what is happening is that find the time. Let me first read it. Find the time that it takes from the instant that the 2 particles are released until they collide. And then the 2 particles coalesce. When they collide, the coefficient of friction and all of this thing, that comes later on. So before that, what is happening now? So now what is happening that after 0.5 seconds, this particle P, let me mark it in blue, and let me just remove the color from here. So this particle, the blue particle P, is now at Q. It's right now over here because it has traveled this distance. And what does it have? It has a speed of 3 meters per second. So now, where is this green particle Q? It should also travel further down the plane. So let me work on Q. So if I work on Q, initial velocity is also 0 meter per second. And this time I'm interested in what is happening after 5 seconds. But before that, what I need to do is to find the acceleration on this rough plane. So we have mg sine theta, and we have F max. Now, what is F max? F max is mu r, that is mu into mg cosine of theta. So now let's do the calculation. That is mg sine theta minus mu mg cosine theta equals to ma. So get rid of the m, take g common out. So 10 is taken common out. Sine theta, that is 0.6 minus mu. How much is mu? Mu is 0.25, 1/4. And cosine theta is 0.8 equals to a. The m gets cancelled out. So 0.6 minus 0.2, that is 0.4 on the inside, 10 on the outside equals to a. Therefore, a is 4 meter per second square on the rough plane. Now, since m cancels out, it doesn't make a difference whatever the value of m is. Coincidentally, the m is the same for both, but the acceleration on the inclined plane, whether rough or smooth, it does not depend on m. So that is 4 meter per second square. So now, again, let me take this data for Q, and let me just slide this thing a little bit to the side, and this thing a little bit up, and let me resize it, make it smaller. So that goes like this. And let me draw some vertical lines, something like this, something like this. So now let me do the calculation for Q. So that is the Q. And now we have the acceleration as 4 meter per second square. Now I can evaluate two things. The first thing is that let me use V is equals to U plus AT. What is the velocity after 0.5 seconds? So U is 0, A is 4, and this is 0.5. This comes out to be 2 meter per second. And then what else do we have? We have V square is U square plus 2AS. 2 square is 0 square plus 2 into 4 into S. So therefore, this is 4 and this is 8S. Therefore, S comes out to be, if I'm not mistaken, this is 0.5 meters. So now what has happened is that P has moved 0.5 meter down the plane, Q actually, and this is Q over here. So this is after 0.5 seconds. So P is at B, Q is down the plane. The speed of Q is what? That is 2 meter per second. Now what is happening is that the difference between the two, because it is over here, it has moved down, this difference is 0.5 meter. So now what I'll do is that a classic case of a kinematics question in which one particle is trying to reach the other, overtaking question. The motorcycle and the car, they want to overtake one another so that the displacement is the same. Now, first of all, what we do is that, let me write on the next page, that is very left, displacement of P, the particle P, it's at the back. It's before the other particle. So not only will it have to cover what Q is traveling, and as well as that difference of 0.5 meter. So SP is equals to UT plus half AT squared, that is 3T plus half into 4. They both are on the rough plane now. T squared. This is 2T plus half into 4 into T squared. And the T is what we are looking at, plus 0.5. So let me use the same color. SP, that is this. SQ, that is this. And this 0.5 is the distance between the two. So now look at the calculation, very simple. This half into 4t square, half into 4t square gets cancelled out. 3t minus 2t, that is t. So t comes out to be 0.5 seconds. That means they will overtake each other after 0.5 seconds, correct? Now, there was one part. Actually, I moved to the next part. But before that, find the time that it takes from the instant the two particles are released when they collide. So this took 0.5 seconds. This also took 0.5 seconds, as we have seen in the calculation. So therefore, the answer for this part is the total time taken is 0.5 plus 0.5, which is 1.0 second. That is the answer for this part. Now I have actually moved to the next part. Now it says the two particles coalesce, they become one single unit when they collide. The coefficient of friction between the combined particle and the plane is still 0.25. Find the time it takes from the instant that the particles collide. So now the story is about the two particles colliding until the combined particle reaches C. So we have to see how much of the distance is left. So now, first of all, they are 0.5 meter apart. Now we have to see where they collide, how much further distance have they covered from the perspective of P or from the perspective of Q, let's see. So it takes another 0.5 seconds. So therefore, let me use blue marker for P. SP is equals to, not SP, actually we need V is equals to U plus AT. VP is U, which is 3, and A is 4, and T is 0.5. So this comes out to be 5 meters per second. And when we talk about VQ, that is 2 plus 4 into 0.5. So this is 2 plus 2 is 4 meters per second. Now, what else should I calculate? I should calculate that they have these speeds, and now they will collide. So now, will they be able to cover some distance? Of course, they will. They will cover some distances on their own. So let me first do that calculation. So there are two approaches. What I can do is that let me find the overall speed, and then I can work it out. That is one possibility. Or the other possibility is I can say that how much distance have they covered when they are overtaking. So now from 3 till 5, basically this is what is happening. From 3 till 5, I can use this thing and I can find the time taken. So therefore, and I can find the distance also. So V square is U square plus 2AS. So let me write this equation at the top. Not this thing, I need this one. Okay. And then over here, so V square, 5 square is equals to 3 square plus 2 into 4 into S. 25 minus 9, 16. 16 divided by 8. So S is equals to 2 meters. This is from perspective of P. If I talk about Q, so I'll write 4 square is equals to 2 square plus 2 into 4 into S. So 4 square is 16. 16 minus 4 is 12. 12 divided by 8, therefore S comes out to be 1.5 meter. This is from perspective of Q. Now, let's look at it. Basically, what's happening is that P was 0.5 meter. P, this blue one is P. P was 0.5 meter behind Q. So it has to cover up a distance of 2 meters before they collide. Or Q was 0.5 meter ahead, so it just have to cover 1.5 meter. Naturally, they would meet at the same place. So let me first use this. That is 3.25 minus this distance 2. So now 1.25 meter is left. So first thing is 3.25 minus 2 meter. This is from B till a point, let's call it M. How much distance does it cover? It covers 2 meters. So therefore 1.25 meters left. to cover as a single coalesced particle. So that is the game plan. So now we have to apply momentum. So what is the working? The working is there is particle P, there is particle Q, and let me make it into one unit. So now the masses are M and M. So this is M, this is M, this is M plus M. The speeds are how much? Just before they are colliding. That is when they are meeting. So one of them has a speed of 5 meters per second. The other one has 4 meters per second. So therefore, we can say this is before, this is after. So total momentum before collision is total momentum after collision. So Tm, that is total momentum. Now, these kind of questions require a lot of cool thinking. You cannot just hurry into all these things. So therefore, M into 5 plus M into is M into 4. This is equals to 5 plus 4 is 9 into the new speed, which is V. So this is 9M. Actually, this is 5M plus 4M. So that is 9M. I think I made a mistake or something. So over here, this is 5 into M, 4 into M. No, that is not 9, that is 2. The 5 and the 4 were speeds. The masses are M plus M into V. So 9M is equals to 2 MV, MM cancel. Therefore, V comes out to be 4.5 meters per second. That is the velocity of the combined particle. And this has to cover a distance of 1.25 meters. So now the ending of the story is this particle is going down. It's accelerating at 4 meters per second square. It has a speed of 4.5 meters per second. The distance that it needs to cover is 1.25 meter. So U is 4.5, A is 4, distance is 1.25. So let's calculate. We need to calculate the time it takes from the instant that the particles collide until the combined particle reaches C. So basically, it's kinematic. So therefore, V square is equals to U square plus 2AS. That can be done. And does it need the speed also? No, they are not asking for the speed. So therefore, I can just use V square is equals to U square plus 2AS. So this is, no, I'm not using V. So therefore, I can use, I can calculate V also. V square is U square, which is 4.5 square plus 2 into 4 into 1.25. So therefore, V square is coming out to be 30.25. Therefore, V comes out to be 5.5 meters per second. So instead of using S is equals to UT plus half AT square, I prefer this. So now let me use V is equals to U plus AT. 5.5 is equals to U, which is 4.5 plus A. How much is A? A is 4 times T. So therefore, this is 1 divided by 4. So T comes out to be 0.25 seconds. It takes 0.25 seconds to reach the C. So it was one of the most elaborate questions on kinematics that I've seen. As you can see, I did not use a calculator at any place except for this one. And the rest is just basic working. And that completes the question. So this is 4:09 right now. So let's see how much time does it take. So 3:48 till 4:09. 3:48 till 4:09. So yes, it took me 21 minutes to explain this question. So yes, the last question is always like the distinction material, the A-star material question, and you have to be very vigilant on how to solve it. Till the next class, take care.